In this video, we're going to look at an optimization problem. We're going to find the area of the largest rectangle that can be inscribed in a semicircle of radius 5. So here's a picture. You've got your semicircle and then a rectangle inscribed inside of it. The radius of the semicircle is 5. So we want to come up with the rectangle which has the largest area. So we're going to need dimensions. So we'll let this side here be x, this one be y, and then this side will be x. So x will just be sort of half the length of this rectangle, so that the area would be 2x y. So the reason you don't let x be the whole thing, you could, but in order to relate x and y, we're going to need to look at this right angle triangle, so it's easier if it's just one side of the triangle is x. Now, you've probably solved this question before, or one similar to this. What you need to do at this step is find an equation which relates x and y, and then make a substitution. So the equation which relates them is x squared plus y squared equals 5 squared, Pythagorean theorem. And then you can solve for either variable. Say you solved for y, so it'd be 25 minus x squared, and you take the square root, and you could take that and sub it in to this, and then take the derivative with respect to x. Now I'm going to show you a different way to do that, and to do this question, and this is using trigonometry. So what I'm going to do is this right angle triangle, I'm going to let theta be this angle here. And then I have my basic trig ratios. So the cosine of theta is equal to the adjacent side, which would be x over 5. The sine of theta would be equal to the opposite side, which is y over 5. So x is equal to 5 cos theta, and y is equal to 5 sine theta. So now what I'm going to do is I'm going to take both these things and sub them into this equation up here. So the area equals 2 times 5 times the cos of theta times 5 times the sine of theta. Putting that all together, you get, well, the 5 times the 5 is 25. I'm going to move the 2, so I'm not going to expand 25 times 2, and the reason is that's going to let me simplify this a little bit. Notice this thing right here inside the bracket, that's your double angle formula for sine 2 theta. Right? Sine 2 theta equals 2 sine theta cos theta. So I'm going to make that substitution. Now the area is equal to 25 times sine of 2 theta. And now I have a function for area in terms of just one variable. That variable is theta. So I should be able to take the derivative, set it equal to 0, and find the critical numbers. I could have done this without making this substitution and having cos theta sine theta, but then I would have to use the product rule. So it's just a little easier if you recognize this identity. So I'm going to differentiate with respect to theta. So 25, I'm going to get 25. The derivative of sine theta is cosine 2 theta, times the derivative of 2 theta, which is 2. So setting the derivative equal to 0, I'll get 50 cosine 2 theta. So when does cosine 2 theta equal 0? Remembering that theta was an angle in a right angle triangle, so it must be less than pi by 2, but bigger than 0, which means 2 theta must be less than pi, but bigger than 0. So when does 2 theta equal 0? So cosine is 0 at pi by 2. Dividing both sides by 2, I get pi by 4. So this is the critical number. Now I just want to show that this was a maximum. So remember, theta was between 0 and pi by 2 was the critical number. So pi by 2 to, pi by 4. Pi by 4 was the critical number, and then pi by 2. So I have to look at dA, or d theta by d, dA by d theta. So remember, dA by d theta was, just remind us, dA by d theta was, I think it was 50 cosine 2 theta. So if you took a number between 0 and pi by 2, cosine would, dA by d theta would be positive. Between pi by 4 and pi by 2, it would be negative. So we go from increasing to decreasing. So there is a maximum value. Now we just have to figure out what that maximum value is. So you need to evaluate your area equation, which was 25 sine 2 theta when theta equals pi by 4. So it's 25 sine of 2 times pi by 4, which is 25 sine of pi by 2. Sine of pi by 2 is of course 1. So that would be 25 times 1, which is 25. So therefore, the maximum area is 25, and we don't have units, so we could just say square units, whatever those units happen to be. Okay, so that's an optimization question that we were able to solve using trigonometric differentiation rather than any other type of differentiation which we had done previously.